Hey guys, so I want to go over your exam for review with you. So let's go ahead and head over to that and see what we got. All right, so first question here, solve each equation. And you know, the advantage of this is you're going to see me work through these, and then you can also pause and go back and that sort of thing. If you haven't tried these yet, please try them before you just watch me go through them. Okay, so 2x minus 7 equals 9. We want to isolate the variable. Remember, anytime you're solving an equation, you're isolating the variable. And so I'm going to add 7 to both sides because I want to undo the minus 7. And so that gives me 2x equals 16. Divide both sides by 2. And we have x equals 8, okay? So there's 1a. 1b, well, we've got 5 plus 2 times 3x minus 1 equals 7. And so notice that this variable is inside parentheses, right? And we can't combine the 3x and the 1 because these are not like terms. So how do we get rid of those parentheses, bring the variable out? Well, you distribute, right? This 2 distributes over subtraction. And so we have 5 plus 2 times 3x, which is 6x, plus 2 times negative 1, so minus 2. And of course, this equals 7. We have like terms over here, right? 5 minus 2, that's 3. So 3 plus 6x equals 7. And then I'm going to subtract 3 from both sides. Again, my goal here is just to get my variable isolated. So we have 6x equals 4. Divide both sides by 6. And we've got 4/6, and we can leave it as a fraction. That's totally fine. Just make sure that it's reduced. So 4/6 reduces to 2/3. All right, part C. So what we're going to do in part C is notice that I've actually got 3 different denominators, right? I've got a denominator of 2. I've got a denominator of 1. And I've got a denominator of 10. Now, the LCM, the least common multiple of 2, 1, and 5 is what? Well, it's 10, right? Actually, I think I might have called that 10 and not 5. Sorry about that. I'm just thinking ahead. So we have 3 denominators, 2, 1, and 5. All 3 of those denominators go into 10. So I'm going to multiply every term by 10. And so watch what happens when I do that. And again, this is, you know, the advantage of multiplying by that least common multiple is that after you do so, your fractions are gone, right? So 2 goes into 10 5 times. And so I have 5 times 5x minus 1. And then let's see what else is going to go on. Right, 5x minus 1. And then over here, well, 10 times 3, that's just 30. And then 5 goes into 10 twice. And so we have 2 times 2, which is 4. Keep this going. 25x minus 5 plus 30 equals 4. We have a common, or I'm sorry, we have like terms, right? Minus 5 plus 30. That'll be plus 25, which equals 4. Subtract 25 from both sides. Oops. Four minus 25 is negative 21. And so I have 25x equals negative 21. Divide both sides by 25. And we have x equals negative 21 25ths, okay? And there's my solution, okay? All right. Next problem. An employee is paid time and a half for working over 40 hours. Last week, the employee worked 52 hours and was paid $957. What is the employee's hourly wage? Well, I'm going to let X be the hourly wage. And so 52, right? That means, so 52, I need to break up, right? That's 40 plus 12. So this means he has 40 hours at his normal wage and 12 hours at 1.5 or 1.5 times his normal wage. Okay. So this payment of $957, this came from two places, his regular wage plus his overtime. And so I want to create an expression for that, right? He worked 40 hours as normal wage plus, and then 12 hours at 1.5 times his normal wage. And together, that gave us a total of $957. So let's see what we get here. 40x plus, and then 12 times 1.5. Well, that's 18x, which equals 957. And so what do we get? 58x equals 957. Divide both sides by 58. And let's see. And again, use your calculator here, okay? We're going to have 957 divided by 58. So the wage is $16.50. Okay, and that's per hour. Okay, per hour. All right. The next problem. All right, so proportions. How do you solve proportions? Well, we learned in class, you cross multiply. So x times 9, better known as 9x, and 3 times 5 is 15. Divide both sides by 9. And then again, leave this as a fraction, just reduce it. So if you reduce 15/9, you get 5/3. If you wanted to make it a mixed number and call that 1 2/3, that would be fine as well. No big deal. All right, B. Well, this is also a proportion. So we're going to, again, cross multiply. 2.4 times x is 2.4x. Do not worry that these are decimals. That doesn't change the procedure in any way. And then 1.8 times 1.5 is 2.7. And then we're going to divide both sides by 2.4. And what do we get? Well, we get x equals 1.125. Okay? So how do you solve a proportion? You cross multiply, you wind up with an equation, you solve for x. All right. Problem 4. So here we're going to apply a proportion. And you've all heard that your weight is different depending on what planet you're on or how far you are from the sun, things like that, or other objects. So we're going to look at the moon versus the Earth. And so we're told that 1 pound on the moon is equivalent to 6 pounds on Earth. That gives me a ratio. And when I set up my proportion, what I need to do is be consistent. So in other words, if I put my moon weight on top, my earth weight needs to be in the denominator. So moon weight over earth weight is going to be moon weight over earth weight. Well, why do I have two proportions here? Well, let's think about this. 1 pound is equivalent to 6 pounds. So 1 over 6. There's my first ratio. And then over here, 37 pounds on the moon. Well, look how I set this up. Excuse me, I put moon in my numerator. So I would have 37, and then I don't know the earth weight. So that's x. Well, cross multiply, and you get x equals, well, 6 times 37, which is what? Well, 6 times 30 is 180. 180 plus 42 looks like 222 pounds. Okay. Now, could you have done this the other way? Could you have said, well, let's do Earth over Moon? Sure, you could have. In this case, you'd have 6 pounds over 1 pound equals, and then make sure on the other side, your other ratio is also Earth over Moon. You'd have x over 37. Notice, when you cross multiply, you have the same products, right? And so there you have it, okay? So don't get too caught up in having to do one on top and one on the bottom. Just make sure that you're consistent. If you're going to put the moon weight in the numerator, then both ratios have to have moon weight in numerator and earth weight in denominator, and vice versa. All right. Excuse me. Okay. A map has a scale where 1.5 inches equals 15 miles. On the map, two cities are 6.75 inches apart. What is the actual distance between the cities? And so here we have a choice to make, right? Because we've got map distance and we've got actual distance. So I'm going to do map distance over actual distance, which means both of my ratios are going to have a numerator from the map and a denominator from actual distance. Okay. And if you need to, add this step so you remind yourself what you're putting where. So map distance, 1.5 inches to 15 miles. 1.5 inches is equivalent to 15 miles. And then again, I put map in the numerator, so two cities are 6.7 inches apart. What is the actual distance? That I don't know. Okay. So now I multiply. Cross multiply. 1.5 times x equals 6.75 times 15. And so you go ahead and do that. 6.75 times 15. We're going to get 1.5x equals 101.25. Divide both sides by 1.5. And we're going to get 67.5 miles. Okay. All right. Now, there are other ways to do this. You also could have said, well, notice that 1.5 times 10 is 15, right? 1.5 inches, 15 miles. So if I'm starting with map distance, I could just multiply by 10 to get actual distance. That works as well. To be honest, it's not always as clean as, you know, having to just multiply by 10. You might not be able to look at it and just see. But either way, there you go. Let's go on to the next one. All right, percent problems. Excuse me, sorry guys. So a pair of jeans costs $30. The jeans are discounted 15%. What is the sale price? Well, there are a couple of ways of doing this. Here's the first one. Solution 1. Here, I'm going to find the discount. The discount is 15% of $30. Okay? And so I'm going to say discount over 30, right? Because that's the is equals percent, 15% over 100. Cross multiply. 15 times 30 is 450. Divide both sides by 100, and you get 4.5 or $4.50. But we're not asking for the discount, we're asking for the sale price, right? And so the sale price then, now that I know the discount, the dollar amount of the discount will be that $30 minus the amount of my discount. Let's just do this. Which turns out to be what? $25.50? Okay, so there's one option. There's a second way to do this, and in this case, instead of saying that the discount is 15% of 30, I'm going to say the sale price, not the percentage, but the actual sale price is, well, let's think about this. The price, 100% of the price is $30. If we take 15% off of that, then we're only having to pay for 85%. So the sale price is 85% of $30. And so what happens now is I have is over of, so x over 30 equals percent over 100. And so 100x equals, and again, if you need to, take a moment and grab a calculator. And then we divide both sides by 100. And so we get, hey, what do you know? 25.50. So in either case, we get same answer, right? So in solution 1, I found the dollar amount of the discount is subtracted from the total price. In solution 2, I said, well, what percent of the total do I actually have to pay if if 15% is being, knocked off? Either way, get the same answer. All right. Car that normally costs $25,000 is sold for $17,500. What is the percent discount? Well, let's see. We could say this. We know the amount of the discount. Right? How would you find that? Well, we know what it normally sells for. And we know what it actually sold for. And so that discount will be, don't know why I'm grabbing a calculator here, but that's all right. 17.5. Whoops. Okay, so right now we know the amount of the discount, but we want the percent discount, okay? But I could phrase this a certain way, right? I could now say that $7,500 is what percent of $25,000. And that's exactly the kind of form I want, right? Is over of equals X over 100. Cross multiply. And then we're going to divide. And, whoops. We're going to get 30. So the percent discount, 30%. Okay? Now, as you're watching these, you're like, well, I did it differently. That's fine. I don't want you asking yourself questions like, well, do I have to, like, say, write this line? No. But I guarantee whether or not you write this line or whether or not you realize it, this is actually what's going on in your thinking, okay? So, you know, don't look at these solutions and get too caught up in the do I have tos. Try to understand what's going on. That's the most important piece of advice I can give you. All right. And then, sorry guys, I realize we got 2 more to do here, which I forgot to put on here. So let's put the next one on. All right, studies show that 28% of high school math teachers have a degree in mathematics. How I wish this weren't true, but it is. Approximately how many do not have a degree in mathematics? Well, and there are 127 math teachers in a particular city. So if 28% do have a degree in math, then what percent do not? Well, 72% do not. Where did this come from? Well, it's 100% of math teachers minus 28% that do have a math degree, okay? And so now what we're saying, there are a total of 127 math teachers. So of those 127 math teachers, we estimate that 72% of them do not have a math degree. We cross multiply. $72 times 127 is 9,144. Divide by 100. And we're going to get 91.44. So we'll say about 91 teachers who teach math of those 127 total do not have a degree in math. Okay. All right, and our last one. Let's see here. Sorry, guys. So we've got a car is traveling 80 miles per hour. What is its speed in feet per second? Well, miles per hour to feet per second. So think of miles per hour as miles over hours. And I'm going to multiply until I get this thing down to feet per second. Now, miles and feet. I'm going to multiply by miles over feet, or feet over miles, right? Because that way, I'll call these MIs, right? The miles will cancel. And then I'll be left with feet and hours. So the next thing to do is deal with the hours, right? Well, how about hours over minutes? Because then the hours will cancel. And at this stage, I'll be left with feet and minutes. And then minutes and seconds. The minutes will cancel, and I'll have seconds. Notice my only units left here will be feet in the numerator, seconds in the denominator, feet per second, okay? So this is a game plan here, right? I'm gonna start with my 80 miles per 1 hour. And now I wanna get rid of my miles, turn them into feet. So 5,280 feet in 1 mile. If I left it here, I'd have my speed in feet per hours. And then times, my feet are good, but I've got these pesky hours over here. So I'm gonna say 1 hour is 60 minutes. That gives my hours, that gets my hours out of there. If I left it like this, I'd have feet per minute, but that's not what I want. I want feet per second. So now I need to get rid of the minutes. Well, we know that 1 minute, excuse me, is equivalent to 60 seconds. Now my minutes are gone, okay? And so you're gonna multiply these all out. You'll have 80 times 5,280 feet over 60 times 60 seconds. And let's see what we get. 80 times 5,280 divided by 60 times 60, which is 3,600. And so we get 117.3 bar feet per second, okay? So that's how many feet are traveled in 1 second, right? Walk through this one again. This is one you want to be able to do on your own. You know, going from one set of units to the other, it's an important skill. Those of you that are going to be nurses, there's going to be a lot of conversions and things. Your chemistry classes, this comes up a lot. So go ahead and give this one another go. How would I further recommend you to get ready for the exam? Well, I would retake this exam review and then look at the solutions. Again, try not to be stuck just looking at solutions. Make sure you try stuff on your own first. Otherwise, that's all I got. And hope you guys are staying safe and all is well.